All right, welcome to The Explainer. Today, we're putting on our data architect hats. We're going to tackle one of the biggest challenges in the industry right now, building a data analytics system that actually works across multiple clouds. So think of yourself as the lead architect. We're about to design the blueprint from scratch.
You know, this isn't just some textbook problem. This is the reality for so many organizations. Your most valuable asset, your data, it's scattered everywhere. A little bit on AWS, some on Azure, and of course, a chunk over on GCP. So the real question, the one that keeps people up at night, is how do you build the bridges to bring it all together for powerful, unified insights?
So, just like any good architect, before you even think about drawing a single line on a blueprint, you have to survey the land, right? For us, that means getting a really clear picture of this complex, sometimes messy, multi-cloud landscape that we're about to build on.
And here are the big ones, the fundamental roadblocks you're going to hit. I mean, it's not just that your data is in different places. Every time you move data out of a cloud, bam, you get hit with these massive egress fees that can absolutely destroy a budget. Plus, each cloud has its own way of doing security, creating this complicated patchwork of rules. Data formats can change on you without warning, breaking all your pipelines. And on top of all that, you have to navigate this maze of different data laws depending on where in the world the data lives. It's really a problem of data movement and control.
Okay, so we've surveyed the site, we know the challenges. Now it's time to unroll the actual blueprint. We're going to break this down stage by stage and see how we can build a really coherent system out of all that complexity.
Look, any solid data architecture, I don't care how complex it is, it's built on these three basic stages. First, you need doors to get the data in. Then you need hallways to move it around. And finally, you need a workshop where you can turn those raw materials into something valuable.
So our very first choice is about the front door. With a push model, your data sources are kind of like delivery trucks that just show up and drop off packages whenever they have something new. With a pull model, we're the ones sending our own truck out on a set schedule to go and fetch the materials. This choice really impacts how fresh your data is and how much control you have.
Next up, the internal logistics. Do we bring every single piece of raw material to one giant central workshop to process it? That's centralization. Or do we set up little workshops in each location to work on the materials locally before we even think about moving them? That's localization. And let me tell you, that can save you an absolute fortune on those transport or, egress costs.
So now we have to decide when to actually do the work on our raw materials. Do we clean and prepare them the second they arrive? That's on ingest, so they're always ready to go? Or do we just store them raw and only process them on read, right at the moment someone asks for a finished product? It's that classic trade-off, right? Speed versus flexibility. Okay, our supply chain is designed. Now let's check out the nerve center, the control room. This is the analytics hub, where all the real value gets created from our process data. This is where the magic happens and insights are born.
And for this hub, we've got a few different design patterns we can choose from. We could go the traditional route and just build one massive centralized data warehouse. Or we could use a more modern platform that's built specifically to work across different clouds. Or we could use this really clever approach called federation, which lets us query the data without ever moving it. Each choice has some pretty big consequences.
And really, it all boils down to this one key strategic choice. Replication? Well, that's like making a whole bunch of photocopies of every blueprint and bringing them to your main office desk. It's simple for sure, but the copies can get outdated fast. Federation, on the other hand, is like having a high-tech system that lets you view all the original blueprints remotely, in real time, without ever touching them. It's way more complex to set up, but your information is always live.
Of course, no project gets built in a fantasy land. Every architect has to deal with the real world, with budgets, with deadlines, and with regulations. For us, these are the non-negotiables, the constraints we have to constantly balance.
And this brings us to the fundamental tension in pretty much all of data architecture: speed versus cost. How fast do you need your insights? Do you need answers in milliseconds? You can have it, but it's going to cost you. Can you wait a few hours? Your budget will definitely thank you. These two things are always pulling in opposite directions.
And this table just lays that trade-off out perfectly. With federation, you get that amazing real-time data freshness, but the cost comes from running these really complex, expensive queries across the network. With replication, your data's a little older, a little delayed, and your main cost comes from those pesky egress fees for physically moving the data. There's no single best answer here. There's only the best answer for your specific project.
Now this is so
So important. Before you pour a single drop of concrete, you absolutely must have the rules for security, for data ownership, and for compliance all figured out. Governance is not the coat of paint you slap on at the very end. It's the steel rebar you put inside the foundation that holds the entire structure together.
All right, theory is great, but let's make this real. Let's get our hands dirty and walk through a real-world scenario to see how all these architectural decisions actually come together to build a system that works.
So let's imagine a software as a service company. Their app runs on both AWS and GCP, and it's just spitting out this constant stream of data, events, logs, metrics. Now, the operations team, they need to see what's happening right now on a live dashboard. But the executive team, they just need a summary report every morning. You've got two very different needs drawing from two different clouds.
So our first architectural step is simple. Identify the sources. We've got application events streaming from our services over on AWS, and then we have all our system logs being generated in GCP. Two separate streams, two separate clouds. Now here's our first really smart move. To avoid those killer data transfer costs, we are not going to move the raw data. No way. Instead, we'll do some initial cleaning and aggregation, a local pre-processing step, inside each cloud. We're working on the materials right where they live.
And it's only after that local work is done, when the data is much smaller, cleaner, and more valuable, that we finally transport it to a single unified warehouse. And from that central hub, we can easily power both the real-time dashboards for the ops team and the daily reports for the business leaders. See how that works?
This design is so effective because it cleverly sidesteps these huge common pitfalls. Trying to run constant real-time queries across clouds would be slow and incredibly expensive. Moving all that raw data first would have bankrupted the project. And without clear rules for the data, the whole thing would be super brittle and unreliable. These are the kinds of cracks in the foundation that can bring the entire building crashing down.
And that wraps up our look at the architectural blueprint for multi-cloud data. The final thought I really want to leave you with is this. A good architecture, yeah, it solves the problems you have today. But a great architecture is flexible enough to answer the questions you haven't even thought to ask yet. Thanks for joining me.